To the first DAC Pavilion talk. I'm Bob Smith. I'm the Executive Director of the Electronic System Design Alliance, and it is my pleasure to present the first speaker this morning, Laurie Balch, who's the Chief Analyst at Gary Smith EDA. So Laurie, welcome to the stage.
Thank you, Bob. And welcome to all my fellow DAC attendees. It's good to see you this morning. So as Bob mentioned, I am Chief Analyst at Gary Smith EDA. And in previous years, we know you've all really had fond memories of Gary Smith. He is most certainly an EDA luminary, if ever there was one. He was a premier evangelist for the EDA industry, an expert in design methodology, without a doubt. But from my perspective, one of the most important things he was to me was a mentor. I worked with him for almost 18 years covering the EDA industry. We all worked together at Gartner and then eventually branched out to our own umbrella, named for Gary himself. He is synonymous with EDA. And Gary was also a very, very dear friend. He was an extremely close person, wonderful to know, and is missed very greatly. As you might know, he passed away right after DAC last year. And last summer, there was a memorial to Gary. On our website, you might want to take a look at the video from that memorial or some other information about Gary and about some memorial contribution opportunities that might interest you, because we'll never forget Gary. He is Mr. EDA and always will be. But in his memory, in his honor, in recognition of his love for this industry and commitment to making the world of EDA, the world of design engineers, better, we are continuing with his team of analysts. We've all worked together for many, many years following this industry. The team includes myself, Mary Olson, who's in the back over there, and a number of other analysts as well, Sharon Tan, our analyst in Asia, Nancy Wu, and our advisor, Diana Mooney. So we're a very, very knowledgeable team about EDA, just for sheer time that we've spent following this industry. Now, what you're really here to talk about is what to see at DAC. What's interesting this year is that, unlike in many other years, there's no single overarching theme, a recurrent theme as to a hot new area at DAC. But instead, we have some interesting things happening across the board in this industry. It's really quite distributed across many, many different aspects, many different segments of the EDA market. And we encourage you to sample a variety of different product introductions, announcements, interesting things going on in many segments. Of those segments, one of the key segments remains ESL, the electronic system level. That is certainly, it remains an important part of the next generation of the EDA landscape. ESL and its linkage between hardware design and software design, that is a key element for this industry going forward. So many of the announcements many of the hot things are in that area. Some of the other hot areas at this DAC are analog mixed signal, RF design. There are many announcements in that area that are pretty key, particularly tied to things like the automotive industry, the wireless industry. Analog mixed signal remains pretty important. Verification, another key area, including both formal verification tools as well as verification IP. This remains a very important pain point for the industry, and announcements in that area are highlighted as well. And throughout the CAD and CAM segments of the market, we have a number of interesting things going on too. Physical implementation is a perpetual pain point for engineers, and so announcements of new developments in that area are pretty important, as well as PCB. PCB is, printed circuit board, is another important segment this year as well. But as I mentioned, there's really no one standout market segment. And on the one hand, having interesting things going on across the board in this industry is a very positive thing. It means not all the resources are focused only on the new hottest buzzword. But it's also a little bit alarming, because what we're seeing are a lot of incremental improvements to tools, a lot of gradual announcements, but not so much revolutionary work being done, not so much really out-of-the-box thinking. So that has a little bit of an alarming factor for the future of this industry. Now, some of the electronic system level tools that we highlight, and you should all have at your seats a copy of our What to See at DAC cards. So that captures the top 20 companies that we are highlighting for interesting things to see at this DAC. And a number of those fall into the ESL tools category. We have companies like Agnesys, which is focused on system design automation. And we think that that's a very important future direction for the industry, connecting the high-level design specifications for hardware design and software design very, very early on in the process to make that design flow operate much more smoothly, the co-design of hardware and software. We have DAC EDA, which is focused on integrated development environments, which also ties in strongly to software development instead of purely hardware development. That hardware-software link, that's a very important recurring theme that we think that more focus should be placed on in the coming years for EDA. Another interesting company to visit is Cadence, whose Rocketick acquisition just a short while ago is a pretty promising area. They focus on early stage fast simulation and creating test benches for hardware design early on. Again, it's that early, high level architecting at a higher level that we want to emphasize. Codasip has their UVM test bench System C model development, purely, right in the sweet spot there for ESL as well. And Imperis Software, which does ESL simulation. Again, moving that design higher in the hierarchy, earlier in the process to eliminate those later, hopefully, eliminate those later design problems that can be avoided with thoughtful, careful planning up front. In addition to ESL tools, we have a number of announcements that are interesting at the RT level. Firstly, we have, as I mentioned, announcements in analog mixed signal and RF design. I'm sure we all know ANSYS is a key player in that market, and they have some new developments in their Seahawk tool for simulation optimization through the use of big data. That's words that come from other industries, but they're starting to make their way into EDA. How to use the data that, because certainly designs are full of data, how do we use that data to more intelligently optimize our simulations rather than blindly running simulations that are more piecemeal. So feeding back intelligence into the simulation process to optimize which simulations we choose to run, that's actually one of the more creative, interesting announcements that we think are coming out of this DAC. I'm sorry, some of the other analog announcements. Intento Design is focused on analog mixed signal modeling and creating analog design environments that automate some of the analog design process. Keysight and their ADS tool, also focusing on analog simulation, with all of the emphasis in the industry on wireless and automotive, analog mixed signal and RF, very, very important design opportunities for EDA. Analysis tools are also very important. ANSYS, again, has their AIM product, which is announcing detailed physics models for electromechanical design. Here's another place where we see a lot of linkage between EDA and other market opportunities beyond just purely chip design. So for analysis tools, we see a lot of potential opportunities here for connections between EDA designs and mechanical designs. There's a bridge opportunity there between those two different markets, and folks like ANSYS are capitalizing on some of that crossover. Keysight has some developments in the power analysis area. Again, power has been a pretty important topic for many years, continues to be so, and check out their tools in that space. Mentor Graphics, their focus on analysis tools is a little different. They have introduced power analysis, signal integrity, thermal analysis for the mainstream engineer. They are working on integrating these more high-end, what have traditionally been more high-end analysis capabilities in their PCB tools for the mainstream user. So putting that analysis capability, that simulation capability in the hands of the masses is something that has been tried very successfully in the mechanical design world and bodes well for electronics design as well. It shouldn't just be something that is relegated to the highest level users. You don't need to be always an expert to run analysis. And in fact, you can avoid a lot of late stage problems by even implementing simple analysis early on. So that integration into the PCB tools was a pretty interesting announcement on their part. IP and design libraries. We've got lots going on there. We've got IP cores from Insilica focused on automotive radar systems. We've got Synopsys, which has been announcing enhancements to its designware portfolio. And Ultra SoC, we've got some verification IP. So they kind of cross over between the IP world and the verification world. And speaking of verification, we've got Breaker, which is doing Esl Functional Verification, another important growth opportunity for EDA. The focus on both ESL, operating at an early stage higher level, and doing verification of your architecture early on is a very important opportunity. OneSpin, their formal verification, particularly at the ES level with using System C, is an exciting space to be in. In the CAD/CAM world, for chip design, Micromagic has a number of announcements in the 3D layout space. So wafer stack, looking at how to optimize designs that are for the next generation of processes. There's a lot of interesting work going on there. Teclatech, they are working on on-chip power integrity. That brings into play the power and the RF analysis improvements. Sage DA, integrated DRC flow. That's pretty critical to both verification and manufacturability. And Synopsys has come out with some ICC2 place and route announcements of late, focusing on timing, area, power optimization, seeing what they've got going on in that space would we strongly advise you to check that out as well. And in fact, Cadence also has some interesting announcements in a similar space with their Virtuoso analog design environment. PCB tools. Cadence has announced enhancements to both its OrCAD and Allegro products to handle flex and rigid flex designs. They have some good work going on in that area, whereas Mentor Graphics, as we also already mentioned, has been developing integrated analysis tools into their PCB tools for the mainstream. For manufacturing technologies, de facto has DFT tools that are more integrated into an overall RTL flow. DFT has kind of been one of the unsung heroes of EDA. It's gone through a few years of not being such an exciting area, but we feel that that's a very important focus for the future, that it hasn't gotten the attention that it needs. And so developments in DFT are pretty key. Solito and their design for yield products, as well as ProPlus and their design for yield and SPICE simulation products, are pretty exciting as well. They've got some new technologies out there, some new introductions of new simulation capabilities that are worth checking out. Okay, our EDA forecast. That's our latest forecast for what the EDA growth is going to look like in the coming 5 years. And as you can see, it's not huge numbers. Modest growth, moderate growth for the coming 5 years. Well, what's driving that? We've got a semiconductor industry in flux at the moment. Lots of mergers and acquisitions of late, and particularly very sizable mergers and acquisitions. In the course of the history of this industry, semiconductor M&A activity hasn't been a huge influence on EDA spending. There's certainly some influence, but it's contrary to popular belief, mergers and acquisitions in the semiconductor world don't necessarily drive reductions in EDA spending. However, that may be changing in the coming years, but it's not clear where that's going. So we don't really know what's going to happen with that. But even more importantly, we don't know if there's a slowdown coming in the semiconductor world. There are conflicting opinions on that, but there is kind of an overwhelming belief that there's going to be contraction there. And that is historically a very important connection to EDA growth. EDA cycles do somewhat follow the semiconductor growth cycles, so a contraction in semiconductor design will lead to a reduction in EDA spending. The economic trajectory overall for the overall economy is also quite unknown. There's much debate as to whether or not we're going to be hitting recession right now, or in the near future, and we don't know how that may play out. On the one hand, we've been hearing many economic reports about how consumer spending is up, consumer confidence is up, and on the other hand, maybe there's a recession coming. And most importantly here, we have to admit that the EDA market is maturing. It's time to take our heads out of the sand and admit that we are in a market that is a maturing market. That does not mean that EDA is a dead market. That does not mean that EDA growth is over. That does not mean that EDA is not important and will continue to remain so. But it does mean that these are not the high-flying days for this industry anymore, and we need to perhaps think more broadly about what opportunities are out there for EDA growth beyond what we have considered just the traditional EDA space historically. So those are the actual numbers for our EDA growth projections. And as you can see, for the coming 5 years, we are not having any years in there with double-digit growth. And this is really our first forecast in quite some time that has no years of double-digit growth in the forecast. They are all hovering in the mid to high single digits. That bodes a little bit of trouble, possibly, if we don't get creative about where growth opportunities lie for EDA. This forecast really is looking at if things stay the way they are. If we continue to define EDA with its traditional boundaries of just electronics design, primarily semiconductor design, this is kind of the growth pattern that we think we can reasonably expect. But growth is not a choice. We don't have a choice as to whether or not we want to grow or not. We have to grow. It's mandatory. So how do we do that? How do we look at increasing what those forecast projections are? What are the opportunities out there? There are a few key questions to answer in that regard. What is the organic growth potential for EDA? If we just continue operating the way we have been and define EDA the way we have been, what's the natural growth that we can expect? Well, we think it's pretty much along the lines of that chart I just showed you for our forecast projections. But what if we branch out from EDA? What if we go into other market spaces, other related areas that might have more growth potential in the coming years, that might broaden our scope of what is EDA? How can we do that? What's the cost involved in doing that? On the other hand, what's the cost of just standing still? What is our opportunity lost costs of just remaining in the position we're in and continuing to operate business as usual? And it's unfortunately true, we do need to think about what is the perception of EDA for the investment community, for Wall Street, for the VCs. This is a necessary evil for us. We all know that for EDA, as well as for many other technology spaces, but certainly for EDA, this is not the freewheeling days of the 90s and the noughts where VCs were throwing money at startups. It's much harder to come by new investment capital for an EDA startup now than probably it ever has been. So what can we do to change that, to get around that, to somehow adapt to that reality? So what kinds of future directions can we have for EDA? What are these things that I'm talking about? Well, we already are thinking about IP as being part of the EDA industry, and that's a relatively new phenomenon. IP used to be considered something maybe not entirely separate from EDA, but certainly it wasn't part of the EDA market. It was something related, but on the outskirts. Well, now we don't think about it that way anymore. IP really is pretty core, shall we say, to the EDA industry. So that's an opportunity that we're already pursuing to grow our traditional boundaries of EDA. One of the things to think about, though, is how we can utilize the business models that have been put forth in the IP industry to help EDA, the core parts of EDA, the underlying parts of EDA. Is there anything that we can learn from their business models and somehow adapt them to the EDA world? That might be a useful thing to pursue. But I certainly don't recommend going out there and suddenly calling something entirely different. Medical devices are not EDA tools. The automotive industry is not part of EDA. So what could be considered part of our world? Well, other kinds of design tools. There are other spaces that use all types of engineering design tools that are adjacent to ours and might be of interest to EDA as an area to branch out and maximize opportunities. This does involve expanding what we traditionally think of as our market and adopting a new attitude toward a user base that we're not necessarily so familiar with. And also, there's the opportunity for specialization within vertical industries. We're already seeing some of that today. Lots of talk about the automotive industry, lots of talk about the wireless industry. But I think most of that has been a kind of reactive approach to where our market sees customers coming up with very urgent needs. Maybe we need to be more proactive in going out there and approaching our own new novel vertical industry ideas to expand what we've traditionally thought of as how we tackle problems in this industry. Okay, what are some of these adjacent design markets that I talk about? Embedded software design tools. So we already focus on primarily hardware when we talk about EDA. But there's a whole space out there of software developers who are developing for those end products that our hardware goes into. It's a different user base. They're software engineers, not hardware engineers. But they're all working together. They are working together, often in the same organizations, side by side, but in separate silos. They have great needs for tools that give them the confidence to design smoothly. Their design flow is very haphazard, typically, not very well formulated. And that's an area where EDA providers can have a lot of influence in helping them develop the skills and methodologies that they can benefit from based on our expertise in hardware design. It's almost a $3 billion market today, so there's a huge opportunity there, given particularly how fragmented it is at the moment. On the other side, we've got mechanical design tools. So our hardware is going into some end product, and there are mechanical designers who are developing those things as well. That's a huge market, a $7 billion market. And there are, as we touched on earlier, a lot of connections with EDA in areas like analysis tools, PLM, product lifecycle management, design data management, developing packaging designs. Those linkages are ripe for opportunities to work together and to put our stamp on where we can bring value to the mechanical design world. One of the other potential risks of the mechanical design world that I think we need to be proactive about is that I think more than a few of those mechanical design companies might be thinking about EDA as a potential growth opportunity for them. And so we need to be proactive in thinking about how we can have the first mover advantage and not let them kind of take over our world. Maybe it needs to go the other way, or there needs to be a better connection between those two industries. So there's a risk potential out there that we can't ignore. In the vertical industry focus, what would a presentation be without talking about Internet of Things, IoT? It's in every technology space. We've got all kinds of projects being developed, products being developed for IoT. And so tailoring solutions for different verticals that are integrating IoT into their own industries has a lot of potential for EDA. And just in general, there is a renewed attention on verticals. I can tell you that in the almost 20 years that I've been following the EDA market, when I started, nobody talked about automotive. You would sound like a fuddy-duddy if you talked about the automotive industry or the defense industry. Nobody wanted to hear that. At the same time, the mechanical design world was all about those industries. That was that's their #1 space. But there's been a major shift in EDA in those past 20 years. And I don't know that I've gone into a single briefing of late that has not somehow mentioned the automotive industry. So we're seeing that this focus on verticals is sort of a new thing for us in EDA, and has a lot of opportunity for us to grow by specializing, as opposed to just developing generic tools that are in theory usable by everyone. Now, if you would like more information on any of these things, we've got lots of market research on our website. In addition to the what to see at DAC information at your seats, We have our annual publication of our EDA wall charts that you should have all received, which goes through a detailed, very detailed listing of all the vendors in the EDA world and how we view them as categorized into different market segments. I know we certainly find that a very valuable piece of data, and we hope you will too. We've got definitions on our website, and very shortly we'll be coming out with our full market share and forecast for this year. So we invite you to take a look at what's up there and contact us with any questions. But right now, I will open the floor for any questions that you might have for me at the moment.
Hi. A quick question. $3 billion you mentioned for the embedded. Is the $3 billion for the embedded development tools?
Correct. Embedded development tools is about $3 billion. Yeah, exactly. Just the tools is a huge market.
Just a simple question. Your forecast, was it including IP?
Does it include IP? Yes.
Does include IP.
The forecast includes IP. As of last year, as of our 2014 data, we began to include IP as part of our definition of EDA. So those numbers that I showed for the size of the industry, as well as the growth projections, include IP as well as the core EDA tools.
Thank you.
You mentioned about defense industry. What do you think the opportunities is out there?
I'm sorry, could you repeat that?
You mentioned defense industry. What do you think the opportunities in that area?
Yeah, the defense industry opportunities are a little bit unique because of their focus on not always cutting edge, leading edge processes. They're usually several generations back in their semiconductor designs, as well as their focus on high reliability. They have some particular unique needs. And so that's where it really comes into some of that vertical specialization, because what the defense industry needs is typically not what your generic consumer markets need. Tailoring tools for just them has a lot of potential, and in particular connecting with the embedded software space, because even the embedded software space has unique tools for defense providers, defense developers. So linking the hardware and software design for defense, they have great needs for automation and simplification of the process. Okay. I don't see any other questions right now, but I invite you to come chat with me later. I'm more than happy to talk with anybody. Thank you very much for your time this morning.